Good morning, good morning, good morning. We are going to continue our work on factoring quadratics. And today we are going to look at removing GCFs, and the differences of squares. So GCF you have heard of since early 5th grade. It is the greatest common factor. And so what you do is you have to find all of the common factors. So we have 1 and 6 and 2 and 3. We have 1 and 12. We have 2 and 6. We have 3 and 4. We have 1 and 18. We have 2 and 9. We have 3 and 6. And that is where we stop. Now, here's the biggest problem with GCFs. Students will pick not the greatest. They'll say, oh, well, 3 goes in both of them, or 2 goes in all of them. But that's the problem. That is not the greatest common factor. So please always remember to find the biggest number in the group. It has always got to be the biggest number in all 3 lists. So you could say, oh, well, 18 is the biggest number, but 18 isn't in all 3 lists. 9, it's not in all 3 lists. So you have to pick the biggest number in all 3 lists, or all of the lists. So it gets kind of hard when the numbers get big. So we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. We have 1 and 32. If you need to use a multiplication chart, you can do that. If you just want to divide by each of the factors, which is the strategy we've been using for finding our factors, that works great. So 2 goes in, 3 does not, 4 goes in, 5 does not, 6 does not, 7 does not, but we have reached 8. Okay, 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. So when we're looking for the greatest common factor, it might be best to start on the right-hand side. So you can see, oh, wait, look, yeah, we've got 16. Oh, wait, we've got 24. But remember, it has to be in all 3 lists. Oh, wait, we've got 12 and 12. But the biggest number in all 3 is going to be the 8. So the greatest common factor for 6, 12, and 18 is going to be 6. The greatest common factor for 24, 32, and 48 is going to be 8. What about this list? What we need to notice is there's also a variable. So we could see that there is an x in all 3 of the terms. So we know that at a minimum, we're going to have an x for our GCF. Okay. This is going to be 1 and 2. This is going to be 1, 4 and 2. This is going to be 1 and 8 and 2 and 4. Remember, those are all numbers that we multiply together to get our coefficient. And the biggest number that is in all 3 of them is the 2, which is why the GCF for this is 2x. It is not x, and it is not 2, it is 2x. Well, what happens if there's exponents? Well, if we think about this, this would be x times x times x times x. So there would be 4 x's. Here there would be 3 x's, and here there would be 5 x's. And so really what we're looking at is there's 1, 2, 3, 1, 2, 3, 1, 2, 3 in each group. So the greatest common factor here is x to the third. Another way to think about it is this can be equal to x to the third times x. This is just x to the third. This is going to be x to the third times x squared. So you can see that there is an x to the third for each one of them. Okay, so let's practice it. Well, the reason why we're doing this is because you have to take, sometimes there's going to be numbers other than ones that can be factored. And so you're going to have to actually take the GCF out first before you can factor it. So let's first put it in standard form. I can tell already I have to move the 16 over because it doesn't equal to 0. And remember, when I move it to the left, it changes from a negative or from a positive to a negative. And now it's equal to 0. Remember also that our coefficients or our terms need to be in descending order. So it's going to be x squared and then our x and then nothing. We've got to pay attention. We're looking for x squared, then our x, and then our constant. Okay, now I need to know what my GCF is. So I've got 4, 8, and 16. 4 is 1 and 4 and 2. 1, 8, 2 and 4. 1 and 16, 2 and 8, and 4 and 4. So you might have thought automatically that it's going to be 2, but honestly, the GCF for this is 4. That means I'm going to divide each term by my GCF. Even all the way to the end. Now 0 divided by 0 or anything is always going to be 0. So I know automatically that this cancels out, so I have x squared. 4 goes into 8 2 times. Don't lose that negative that's there, and don't lose the x. And then 16 divided by 4, don't lose the negative. And then if we needed to, we could factor it from there. Right now, we're just practicing putting it in standard form and taking out the GCF. So put it in standard form. That means the 9y has to move to the other side, and it's going to change from a positive to a negative. And as a reminder, it's x squared, then x, and then nothing. So it becomes 3x squared y plus 12xy minus 9y. So we put it in standard form first. Now I have to find my GCF. So if I notice, there is a variable in each term, and that is our y term. So I'm going to take my y out. My GCF is going to be y. And then I can also take out a 3 because 3, 12, and 9 are all divisible by 3. So I'm actually going to be dividing this by 3y. My GCF is 3y. And when I divide each term by 3y, cancel, 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 cancel. That leaves us with x squared. That goes in 4 times. Don't forget our minus sign. It goes in 3 times. But we have to keep in mind that this actually has the factor, it's a greatest common factor of 3y out front. So don't forget to leave it out front. And I forgot that over here on this other one. So we need to keep in mind that this would have a factor of 4. 4. Now, can we factor this equation again? Yes, we could. So we could write this or factor out this equation. And in fact, if the directions were to say factor fully, in fact, I'll go ahead and do that. If the directions say factor completely or factor fully, you would have to do that. You'd take out the GCF and then you'd have to look at this and say, okay, well, I can make my t-chart. It's going to be 1 and 3 because my C is negative. They're both going to be, oh wait, one's got to be a negative and the other one's got to be positive. Well, that must mean I have to use my quadratic equation. And since we haven't talked about that, this is where we would stop. So this is a complete answer. Okay, so again, move our variable term or our term that is on the right-hand side of the equal sign to the left. Make sure we're changing it from a positive to a negative. So, and then we have to put our variables in descending order. So it's our 4, then our 3, then our 2. So it's going to be 10, x to the 4th. The 15 changes from a positive to a negative, 15, x to the 3rd, and then a 25, x squared is now equal to 0. Now we have to find our GCF. So we should be able to look at these and recognize that each of the terms are divisible by 5. So if we remember here, when we were looking above with the exponents, really the GCF is going to be the smallest exponent value. So the smallest exponent value that's available here is going to be our x squared. So we are going to divide each term by our GCF. Don't forget to write it as a term out front. And then 5 goes into 10 2 times. Remember, when we're dividing powers, we subtract the exponents. So we have x and 4 minus 2 is 2. We divide, and 3 minus 2 is 1. We divide, and 2 minus 2 is 0. So please notice we are now in descending order, and everything has been factored appropriately. I'd like you to try the next set. Now let's think about the differences of squares. So difference tells us this is the answer to a subtraction problem. So a perfect square. What is a perfect square? Well, this is a number where their square root is a whole number. We have talked about these. We know that 1 squared is 1. So 1 is a perfect square. We know that 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. These are all perfect squares. So, in order to do problems like this, the first thing we're going to do is put it in standard form and factor out any perfects or any GFs, greatest common factors. So I'm going to move my 128 to the left, so I have 32x squared minus 128 equals 0. One of the things that's important to notice is that these are called differences of square problems. So there has to be subtraction going on between our numbers. So keep that in mind. We're going to be looking for that subtraction shortly, and I wanted to make a mental note. I didn't mention that before. So our GCF of both of those is actually going to be 32. 128 divided by 32 is 4. So we took out our GCF, we divide both of them by 32. So we have x squared minus 4 equals 0. Now, determine if the A and C are perfect squares and B is 0. So we can tell automatically that the B is 0 because there are only 2 terms. That's an easy one. We've got that one. Are the A and C both perfect squares? Well, if the exponent is even, then A is going to be a perfect square. Coefficient is 1. 1 is a perfect square. So yes, A is a perfect square. C is 4. Is 4 a perfect square? Yes, it is 2 times 2. So we now need to take the square root of both A and C. So the square root of A and C, if A is 1x squared and C is 4, and I know I hate putting B in here, but that's what you're going to see when you get into Algebra 2, so I want to make sure you can see it. If you take the square root of both of these, this is going to be 1x, and the square root of 4 is 2. And then all you do is put it into this formula. So we have 1x, or x, plus 2, and then x minus 2. So, turn your paper over and let's try some more. So, step 1 is to put it in standard form. So, 5n squared minus 320 equals 0. Factor out your GCF, and you should get in the habit of doing this all the time. These should be your first 2 steps. Standard form, GCFs. Standard form, GCFs. Standard form, GCFs. So, 320 divided by 5 is 64. So we're left with 5 on the outside, and then we have n squared minus 64. Determine if both our A and C are perfect squares. Well, our exponent is even, and 64 is 8 times 8, so yes. Take the square root of both of them. So the square root of n squared is going to be n, and the square root of 64 is 8. And we're going to apply a plus b and a minus b. So our 5, our a is n, our b is 8. Our A is N. Our B is 8. And there we go. Okay. Move it to the other side. So we have negative 5x squared plus 20 equals 0. Remember, when we move it from the right-hand side to the left, we always change it from a negative to a positive. Then find our GCF. And it is going to be a negative 5. So it's x squared minus 4 equals 0. Determine if our A and C are both perfect squares. Yes. The exponent is even. 4 is 2 times 2. Take the square root of each. So A is going to be x, and B is going to be 2. So we have negative 5, x plus 2, and x minus 2. 2 more practice. Move our variable term to the other, not our variable term, move our term to the other side. It changes from a negative to a positive, so negative 3b squared plus 27 equals 0. Take out our GCF, which is going to be negative 3. That leaves us with b squared minus 9 equals 0. Determine if our A and C are both perfect squares. Excuse me. Well, our A is going to be B, and our B is going to be, the square root of 9 is 3. So our final answer becomes B plus 3 and B minus 3. Move our variable term to the other side. Find our GCF, and I'm sure it is negative 9. Yep. And that is a negative 36 equals 0. Determine if they're both perfect squares. They are. The A is going to be m. The B is going to be, the square root of 36 is 6. So our final answer is negative 9 times m plus 6 and m minus 6. Okay, so there's practice for you to complete. Please rewatch if you need to. Remember, for the GCFs, you're looking for variables as well as numbers. Make sure you're taking the biggest number. And then it is simply, when they're both perfect squares, A plus B and A minus B. Are the 2 things to remember, most important from this. I hope you're doing well and everyone in your family is healthy and happy, and I will talk to you soon.